dimensional have some problem for the end of this session. So just refresh your jump board kapag mukhang hindi nag-update yung sa screen nyo. Kahit naman nag-update ako dito. So you can refresh it para ma-update to. Then problem number one states that the water flows through horizontal pipe of cross-sectional area of 20 centimeters squared. In one section ng cross-sectional area, it is 4 centimeters squared. In one section, the cross-sectional area is 4 centimeters squared. Then the pressure difference between the two sections is 29.4 psi. How many cubic meters of water will flow out in the pipe for 1 minute? So ano yung given sa problem? Ano yung known? Then sabi sa problem, i-highlight ko lang here, that water flows through horizontal pipe. So that is significant. Later, I will show you bakit. And a cross-sectional area ng pipe given din at both section, A1 or A sub 1 and A sub 2. So, area 1 and area 2. Assume na lang natin hindi siya parehas. Or, pagod natin. So this is point 1, then this is point 2. Given dito yung area at point 1, which is 20 centimeters squared, area of point 2, which is 4 centimeters squared, then ang pressure difference, or we can say P1 minus P2 is equal to 29.4 psi. You can say that those are pressure loss also. Kasi from point 1, yung pressure mo bumaba sa point 2. Then ang hinahanap is yung water flowing out of the pipe in 1 minute. How many cubic meters of water will flow out in the pipe for 1 minute? So makita rin natin sa given that unit natin dito is in centimeters squared or in metric unit, while the unit for the PSI or unit for the pressure difference is in 29.4 PSI. So we need to convert pamaya ang PSI into metric unit para maging standard yung ating metric system or yung ating unit system dito sa problem. So analysis, ano ang gagamitin natin ditong equation? We can use the Bernoulli's equation or Bernoulli's theorem. I just copy paste the equation. Okay. So as you can see here, binanggit sa problem na water flows through a horizontal pipe. So if it's in a horizontal pipe, meaning the elevation of point 1 and the elevation of point 2 will remain the same or inconstant. So dito sa equation na to, sa Bernoulli's theorem, we can cancel out both elevation head at point 1 and elevation head at point 2 kasi parehas lang naman sila. P1 minus P2 or P1, P2, given naman siya dito, 29.4 PSI. Unfortunately, si V1 at si V2 is hindi binigay, so we need to compute pa ito. So, para natin kukumpute si velocity 1 at velocity 2, then we need to use the continuity equation. For continuity equation, binanggit dito sa problem na the fluid or the medium is water. So, we will use the equation for compressible fluid. In compressible fluid, it states that the volumetric flow rate at point 1 is equivalent to volumetric flow rate at point 2. Q1 is equal to Q2. Where in Q1 is equivalent to area at point 1 multiplied by the velocity at point 1 and is equivalent to area of point 2 multiplied by velocity of point 2. So given naman ang area at point 1 which is 20 centimeters squared and area of point 2 which is 4 centimeters squared. So to get the value of velocity, we just need to divide A1 over A2, which is 20 divided by 4, we'll arrive to 5. So 5 V1 is equivalent to V2. So 5 times ang velocity 1, equivalent niya is velocity 2. Now, two unknowns, we have already two equations. We can solve for the value of the velocity. But let's transpose first the equation of Bernoulli's theorem into the other form. So we can say here that P1 minus P2, or pressure of point 1 minus pressure of point 2, which is equivalent to 29.4 psi, divided with the specific weight of water, is equivalent to V2 squared minus V1 squared divided by 2G. So first, let's convert the value of 29.4 psi into metric unit. It should be in kPa. So we know that for every 14.7 psi, there will always be 101.325 kPa. So let's convert it. 29.4 times 101.325 divided by 14.7. So our value for the change in pressure or the pressure drop would be 202.65 kPa. So let's substitute those values here in the new equations. So we'll get P1 minus P2, which is 202.605 kPa or kilonewton per meter squared. 605 kilonewton per meter squared. Divided by specific weight ng water, which is 9.81 kilonewton per cubic meter. So we'll check if every unit now is in standard format para makancel natin yung mga unit. Is equivalent to V2 squared is equivalent to 5V1. So 5V1 squared. We'll need to substitute the value of 5V1 into V2 to the equation. So 5V1 squared minus V1 squared divided by 2 times 9.81 meter per second squared. So 5v1 squared minus v1 squared is equivalent to 5 squared is 25 minus v1 squared will be 24 v1 squared. I-type ko na lang dito din. So let's divide the value. So 202.605 kilonewton per meter squared divided by 9.81 kilonewton per cubic meter times 2 times 9.81 divided by 24 squared. We'll have the value for velocity 1 of, so the value for velocity 1 is 4.109 meter per second. Since lahat naman ng unit nito ay pare-parehas na in meter and per second, so we'll get 4.109 meter per second. But let's cancel it in the equation. So kilonewton, cancel in the numerator. Kilonewton, cancel in the denominator. Cubic meter and meter squared will give us 1 unit or 1 value per meter. Then, multiply natin si meter to second squared will be meter squared per second squared. And then, square root natin yung value. Divide sa 24. So, we'll get meter per second. So, tama naman siya. So, moving on next slides, kasi kinocompute naman natin talaga dito, ang hinahanap natin, total volume ng water flowing out of the pipe in 1 minute. So, nakuha na natin yung value ni V1. So, paano natin makukuha naman yung total volume ng water flowing out in the pipe in 1 minute? So, we just need to determine the volumetric flow rate in equation of Q1 is equals to A1 times V1. So, lahat naman given na, makukuha na natin si volumetric flow rate. So, moving on next slide, Q1 is equivalent to A1 or A sub 1 multiplied by velocity 1. So, area ng pipe is in a unit of centimeter squared. So, convert na natin siya into meter squared by dividing it into 100 squared. So, 20 divided by 100 squared is 2 times 10 to the negative 3. Meter per second, meter squared for the area multiplied by the velocity. Nakuha natin velocity which is 4.109 meter per second. So the value for volumetric flow rate is equivalent to 8.219 or sorry 8.218 times 10 to the negative 3. 8.218 times 10 to negative 3 cubic meter per second. So still we need to know or we need to determine the volume, total volume means the unit must be in cubic meter flowing out of the pipe in 1 minute. So kapag ganito, itatimes lang naman natin si volumetric flow rate sa 1 minute. Pero yung unit kasi ni volumetric flow rate is naka-second. So 1 minute is equivalent to 60 seconds. So times lang natin si 8.218 by 60 which will give us 0.493 volume of water flowing out of the pipe in 1 minute is equivalent to 0.493 cubic meter. So, nasatisfy natin yung problem, na-provide natin yung hinihingi, which is the volume of water flowing out in the pipe in 1 minute is equivalent to 0.493 cubic meter. Ginamit natin sa equation, we do this equation, nineglect lang natin yung value ng elevation head kasi nga the water flows through a horizontal pipe. At the same time, ginamit natin yung continuity equation since siya is since ang fluid that is water, we'll use the equation for the non-compressible fluid. So, kung may tanong kayo doon, just let me know. You can raise your hand. If wala naman, then we can move on to the next problem. Clear naman. Okay, sige. Thank you, Ms. Claudine. Okay, moving to the next problem, ipipaste ko lang dito sa Jamboard on the next slide. Okay. Our next problem states that the water flows steadily with a velocity of 3.05 meter per second in a horizontal pipe having a diameter of 15.24 centimeter at one section of the pipe. The temperature and pressure of the water are 21 degrees Celsius and 689.3 kPa respectively. At a distance of 304.8 meter downstream, the pressure is 516.9 kPa. So ang hinahanap is the friction factor. What is the friction factor? Again, let's analyze the problem first. So the water flows steadily with a velocity of 3.05 meter per second. So essential yung term na ginamit dito, which is steadily with a velocity of 3.05 meter per second. Kasi ina-assume natin that the velocity of the water, yung fluid dito, which is given water again, non-compressible na naman, is that constant throughout the pipe length. So it will remain the same 3.05 meter per second inlet and outlet. Additionally, binanggit na naman niya na it is in a pipe natin, meaning there will be no change in elevation between 2 points, or the elevation of the pipe will remain the same throughout the length of it. Pag sinabi natin elevation, ito yung taas nung pipe natin kung saan siya nakalagay in reference to kung ano man yung reference na position natin. So kapag horizontal pipe, the elevation on the inlet will be the same sa elevation sa outlet. So what is known in the problem? It is known that the water flows steadily and it is in horizontal. The pipe is in horizontal position, or the water flows steadily in horizontal pipe. Given din yung diameter ng pipe. Pati yung pressure at both ends is also given. The length ng pipe is given din. Binigay siya using at a distance of 304.8 meters. So yun lang gagamitin natin dito itong constant or figure, the 304.8 meter. So yun ang hinahanap sa problem. we need to find the friction factor. So given will be velocity is equivalent to 3.05 meter per second. Pipe diameter is equivalent to 15.24 centimeter. So the diameter of the pipe, ang unit niya is in centimeters, so i-convert lang natin siya into meter. Lahat naman ng binigay dito is in metric unit na. So wala na tayo kailangan i-convert kundi yung diameter ng pipe lang. So pressure at point 1 will be 689.3 kPa or kilonewton per meter squared. Then pressure at point 2 will be 516.9 kPa. Then friction factor of, length of the pipe, which is 304.8 meters. So anong equation ang gagamit natin dito? Analysis. Based from the given and based from the problem, since ang hinahan is yung friction factor, then gagamitin natin si Darcy-Weisbach equation. So let's analyze the equation, Darcy-Weisbach equation, kung lahat ba is given. Ang hinahanap natin si friction factor. So okay lang yan. Then length of pipe, nabigay to. Velocity ng fluid, given to, 3.05 meter per second. Acceleration due to gravity, constant, 9.81 meter per second squared. Diameter ng pipe is given. However, the H major or the major loss within the pipe ay hindi binigay. So hanapin natin to. So we still need to find the major loss in the pipe. So by finding major loss in the pipe, we need to use the Bernoulli's equations again. Bernoulli equation, I'll just post here. It states that the energy in the pipe, which is represented by the pressure head at point 1 plus velocity head or kinetic head at point 1 plus the elevation head at point 1 will be equivalent to the pressure head at point 2 plus kinetic head at point 2 plus elevation head at point 2 plus the major head losses. Now we need to correlate this H major or major head losses here in Darcy-Weisbach equation to the major losses given in the Bernoulli's equation. So this is equivalent only. So again, let's analyze the Bernoulli equation. Sabi nga dito, water flows steadily in the horizontal pipe, meaning ang velocity 1 mo is equivalent to velocity 2. So pag pinag-subtract mo sila, mag-zero lang din naman sila. So let's cancel each other out. Again, the water lies in, or the water flows in horizontal pipe, meaning same elevation lang sila, same reference point. So yung elevation head natin at point 1, kapag pinag-subtract mo sa elevation head at point 2, masisiro lang naman sila. Kaya cancel na lang natin. Leaving us with the pressure head alone. So P1 minus P2 divided by the specific weight ng water is equivalent to the head loss. So let's move to the next slide. I'll just type it down. So P1 minus P2 divided by the specific weight ng water, kasi water yung medium natin, is equivalent to the head losses. So once na nakuha natin yung value ng head loss, isa-substitute lang natin ito dun sa Darcy-Weisbach equation. So P1 minus P2 is is equivalent to 689.3 kPa minus 516.9 kPa divided by 9.81 kilonewton per cubic meter. So 689.3 minus 516.9 kilonewton per meter squared divided by 9.81 kilonewton per cubic meter. This is equivalent to the HL or the major head loss na hinahanap natin. So let's cancel the unit, kilonewton to kilonewton, meter squared to meter, leaving us with a single unit of meter here in the numerator. So HL will be 689.3 minus 516.9 divided by 9.81 will be 17.574 meter. The unit ng head loss will be always in meter kapag itong formula ang ginamit natin. Is in Bernoulli's equation here is in head form. So HL or major head loss is equivalent to 17.574 meters. So balikan natin yung equation ni Darcy Weisbach. So meron na tayong value ng H major or ng major head loss. Meron tayong value ng depth ng pipe, velocity ng pipe, acceleration due to gravity, in the diameter ng pipe. Then makukuha na natin si friction factor, yung hinahanap sa problem. So friction factor, transpose lang natin, is equivalent to HL multiply by 2, multiply by G, multiply by the diameter ng pipe, divided by LB squared or length ng pipe, multiplied by velocity raised to the second power. So substituting the value to the equation, HL is 17.574. Will be 0.0185. Dimensionless number, meaning wala siyang unit. Okay, going back to the problem, analyze na muna ulit natin. Gumamit tayo dito ng Darcy-Weisbach equation kasi yung hinahanap is si friction factor. At the same time, gumamit tayo ng Bernoulli equation para ma-determine naman natin yung major head loss due to the drop in pressure kasi wala nang ibang nag-constitute ng major head loss dito kundi yung pressure drop lang. Kasi na-cancel out natin si velocity head, na-cancel out natin si elevation head. So yun, first thing, analyze the problem, check natin kung ano yung given, ano yung condition, then saka tayo mag-come up sa analysis. May tanong pa tayo dito?
Wala naman.
If wala din. Sakto naman. Actually, kahit naman tatlo lang. Pero considering kasi na ganito, kung makikita nyo si friction factor, napakaliit na kasi kung magiging tatlo. Kasi it starts with 0 agad. So, 0.018. So, kapag naman mga full number siya, then at least 3 naman. Pero kapag mga 0.0 yung pinag-uusapan natin, then make it 4 para naman hindi mukhang erroneous yung sagot natin. Thank you din. Thank you for the question. Then, if wala na, let's move to the next problem, our last set of problem for today. Just give me a minute. Wala ako ng tubig. Okay, thank you for waiting. So, let's start with the third problem para matapos tayo na maaga. So, please check the fifth slide for our third problem set. So the third problem states that what is the expected head loss per mile of a closed circular pipe with a 17 inches diameter and a friction factor of 0.03 when 3,300 gallons per minute of water flow under pressure. So medyo mixed yung unit na ginamit dito. Everything is in inches, then gallons, then in minute. Then binigyan pa tayo ng length ng pipe which is 1 mile. So ibang unit din yun. So the thing is, we need to convert din datang yan into a standard form para hindi tayo malito. Then konting trivia lang din when we discuss about the pipe. In reality, wala naman talagang 17 inches pipe. So I'll just share here some table regarding the pipe schedule. So when we order pipes, kapag nasa procurement tayo or during design stage or construction stage, we always use the nominal pipe size while ordering. It will be into 6 inches, 6 DN6, 8, 10, 15. So wala kang makikita dito na 7-inch pipe. Pero ito yung binigay sa problem, and for the sake of calculation or review lang naman, then you'll get used to that. And thickness ng pipe will be always into schedule. So kapag binanggit natin is schedule 40, schedule standard, schedule 60, XS, there's a corresponding thickness ng pipe para doon. So ang order natin when it comes to pipe will always be the nominal diameter of pipe and the corresponding or kung ano yung hinihingi nating schedule dito. Okay. So let's go back. We'll stick with the 17 inches pipe here. So what is known in the problem? So binigay dito yung length ng pipe. Actually, hindi naman in-specify na ito lang yung length ng pipe, pero ito yung pinapa-compute lang sa atin. What will be the head loss per mile of a closed circular pipe? So, assume na lang natin na ito yung length ng pipe for now. Pipe length, which is 1 mile. Known din ang diameter ng pipe, which later we can convert it into area, friction and friction factor, and the volumetric flow rate. So, ano yung hinahanap sa problem? Ang hinahanap dito is the head loss or the major head loss or denoted by H sub L. So, given length ng pipe is equivalent to 1 mile, later ko-convert natin yan into a standard unit. Compare natin yung mga unit dito sa problem, then convert natin lahat para magkapare-pareha sila. Then, diameter ng pipe, denoted as letter D, which is 17 inches. Friction factor, which is a dimensionless number, so 0.03 lang siya. And volumetric flow rate, which is 3,300 gallons per minute. So, since ang kinukuha dito is head loss and given si friction factor, gagamitin natin si Darcy-Weisbach equation for the analysis. Let's copy-paste the Darcy-Weisbach equation. And let's check if kompleto ba yung mga given na binigay sa problem para ma-solve si head loss. So, given si factor, which is 0.03, given yung length ng pipe, yung velocity is hindi binigay, pero binigay naman si flow rate at binigay si diameter. So sabi ko nga, mako-compute natin ang velocity kapag binigay si diameter kasi ko-convert lang natin to, compute lang natin ang area ng pipe, and ayun, makukuha na natin yung velocity nito. Acceleration due to gravity is constant and diameter ng pipe is given. So first, we need to know for the value of velocity. So start muna tayo sa formula ng flow rate. Flow rate is equivalent to velocity ng fluid multiplied by the area ng pipe. So velocity ng fluid is equivalent to volume flow rate ng fluid divided by area ng pipe. But before that, let's convert first all of these given here into a standard format. Since usually ang volume flow rate natin and ilagay na rin pala natin dito since ang gagamitin nating unit is in English unit. Yung acceleration due to gravity will be in English unit. It's equivalent to 32.2 feet per second squared. So remember yan guys kapag metric unit 9.81 meter per second squared ang ating acceleration due to gravity. Pero kapag siya naman ay English unit, it will be 32.2 feet per second squared. So since volume natin dito, gallon, convert naman natin ito sa feet, i-convert na lang natin lahat into a unit of feet dito. So for the diameter, 17 inches, equivalent to sa, then for every 12 inches, merong 1 feet, so 17 divided by 12 lang yan, it will be 1.417 foot, ang ating diameter. Ang ating volume flow rate, which is 3,300 gallon per minute. Kagaya na sinabi ko kanina, we need to convert it into cubic feet kasi gallon is a form of volume. The equivalent niya will be in feet. So for every 1 cubic feet, there will be 7.482 gallons. So divide lang natin si 3,300 gallons per minute into 7.482. So we'll have 441 cubic feet per minute. Pero si acceleration due to gravity is in second. So let's convert the minute into second by dividing it by 60. So for every 1 minute, there will always be 60 seconds. So 441 divided by 60 is 7.35 cubic feet per second. 7.351 cubic feet per second. So yung length na lang ng pipe ang kailangan natin convert into feet kasi naka-mile to. So the longest conversion is that for every 1 mile, there is 1.609 kilometer. Then 1 kilometer, there will be 1,000 meter. And for every 1 meter, there will be 100 centimeter. And for every 2.54 centimeter, there will be 1 inch. And for every 12 inch, there will be 1 feet. Pero check natin sa internet para ma-convert yun. Mile. So 1 mile is equivalent to 5,280 feet. So i-multiply natin si 1 mile to 5,280. So it's equivalent to 5,200, 5,280 feet. So naka-standard na yung unit natin, everything is in feet and second. So pag multiply natin sila, makaka-cancel out lang nila ang isa't isa. So velocity is equivalent to volumetric flow rate, which is 7.351 cubic feet per second, divided by the area ng pipe. Pero lang pala tayo sa diameter, so convert lang natin to by multiplying the 1.417 squared times pi divided by 4, which is 1.577 feet squared. Then leaving us with the value of velocity of 7.351 cubic feet per second divided by 1.577 feet squared, which is 4.661 feet per second. So velocity is equivalent to 4.661 feet per second. So going back again to Darcy-Weisbach equation, check lang natin kung kompleto na. We have the friction factor, we have the length of the pipe, everything is in feet, velocity is in feet per second, given na din, acceleration 32.2 feet per second squared, and diameter ng pipe, which is 1.417. Makukompute na natin ngayon si H major. So H major or head loss, major head loss, is equivalent to friction factor of 0.03. This is a unit test number, I mentioned this number, multiplied by length ng pipe, which is 5,280 feet, multiply by the velocity, which is 4.661 feet per second squared, divided by 2 times the acceleration due to gravity in English unit, which is 32.2 feet per second squared. Then, and also by the diameter of the pipe, which is 1.417 feet. So head loss is equivalent to 0.03 times 5280 times 4.661 squared divided by 2 divided by 32.2 and divided by 1.417. So leaving us with 37.717 feet. So check lang natin if makakancel out kayo mga units natin. So feet squared over second squared by numerator. Cancel. Feet squared by denominator. Cancel second squared, leaving us with 1 unit of feet here. So tama naman, magiging head loss natin. Hinihingi sa problem for head loss per mile ng closed circular pipe given a condition na ang diameter niya is 17 inches and ang volumetric flow rate is 3,300 gallons per minute using the Darcy-Weisbach equation will be 37.717 feet. So that's it guys. Kung may tanong kayo, just let me know. If may unclear, i-try natin pa-explain. Okay, thank you. Manage that. So, see you on next week. Then, let's have a small introduction muna next week kasi magkakaroon ng face-to-face. Okay, yes, Miss Within, acknowledge. Okay. I-check ko muna ha. Then kapag meron namang update, siguro i-share ko na lang din sa sa may natin, classwork natin. But perhaps mga lang 'yon, mga problem solving lang. Okay, thank you. Then see you by next week guys. Magkaroon tayo ng quiz. Siguro after introduction, short introduction ng bawat isa. Just let me know your name, how can I address you. Then para lang maalala ko yung bawat isa sa atin, bawat isa sa inyo, my name and just your nickname or how we want to address you. Then after that, a small quiz, then introduction again sa alam ko next topic natin will be pump. Specific na tayo sa pump next week. Tama. So it will be more on discussion about the pumps. So, pag wala na tayong tanong, thank you very much for attending our class and sana may natutunan tayo for today.
Thank you po, sir.
Salamat.